So datums are used to constrain the part. Whenever I say, okay, operator, Mr. Operator, I have to assemble one part to another part. So what I do is basically I constrain the part. I make sure that the part does not move in any direction. So datums kind of define the locating scheme, gives an idea to the operator how you're going to locate the part, and also it stops the degrees of freedom for any part. Let's talk about degrees of freedom. So take any part, any physical part which has mass and volume. Okay, it has 6 degrees of freedom, meaning that it can translate along XYZ axis and it can rotate along XYZ axis. Okay, so it has 6 degrees of freedom. When we say to assemble the part, when I say I have to assemble the engine mount to the engine, what I do is I constrain this 6 degrees of freedom. So I make sure that the part doesn't move in any of the direction XYZ, or it doesn't rotate in any of the direction XYZ. Okay, so we'll talk about how exactly we constrain the degrees of freedom in a very nice example that I have at the end of this lecture, and that would give you a very good idea as how the degrees of freedom are constrained. So types of datums. The first datum is the primary datum. So primary datum is nothing but, you can say in a very generalized way, you can say that primary datum is the first mating surface. Okay, so let's say I have this block over here and there is a surface over here. And I tell the operator, okay, Mr. Operator, please attach this block to this surface. So obviously this A is the primary datum, so he will attach this surface to this surface first. This is a very generalized way of saying what A datum is. There are more complex ideas to A datum as well, but we will. That is not something we can cover today. We will definitely cover in the lecture series that we are going to have. But for now, just understand that primary datum is nothing but the first surface that mates to another surface of a part. So if it's an engine mount, so engine mount kind of looks like this. So there's a hole, let's say there's a slot and there are 2 oversized holes. And then this is my engine block over here. And then this surface mates to this surface. So this surface would be my primary datum. Primary datum constrains 3 degrees of freedom. So out of 6, it will constrain 3 degrees of freedom always. Secondary datum. Secondary datum is the second surface or the second feature that attaches to my another part. Okay, it can either be a surface or it can either be a feature. Surface meaning just a plane or any surface as the word suggests, and feature meaning any hole, pin, slot or a tab. So primary datum is nothing but the second surface or second feature that would attach to my other mating part. It will constrain 2 degrees of freedom. And finally, there is 1 degree of freedom left. So primary datum A will constrain 3 degrees of freedom. Primary datum B will constrain 2 degrees of freedom. And finally, I have the tertiary datum. Secondary datum B would constrain 2 degrees of freedom. And finally, I have a tertiary datum C, which constrain 1 degrees of freedom. 3 plus 2 plus 1, 6 degrees of freedom constraint, and the part is finally assembled to my other mating part. That is the main goal of any GD&T engineer, is to how to constrain that part completely so that no degrees of freedom is left behind. So this is about datums, and for now, just understand that datums constrains the degrees of freedom. Primary 3, secondary 2, tertiary 1.